So let's look into threading today. So yeah, initially, in Python, whenever we want to execute threads, okay, before that we need to know what threads are. See, okay, they are nothing but instructions that are being executed over the CPU. So if the CPU is executing a single thread, that means that that set of instructions are being currently run on your CPU, and then so if you have thread 1, thread 2 running simultaneously over the CPU, that means that the CPU is now currently executing two sets of instructions, one from thread 1 and one from thread 2. So yeah, so that's what threads actually are. Now in Python, there is a drawback with not a drawback, but still there's an issue with using threads. If uh, if um, if you're using CPU threads, there is something called as a global interpreter lock. The global interpreter lock would allow Python to execute only one set of instructions at a time. So this is this is counterproductive, right? That means that the CPU, even if you have four CPUs, but at a time one program can only make use of one CPU's. Yeah, so if there is a thread coming in, only he gets to execute in the first CPU. So what about the remaining all? They are not being used at the moment, so there is no way that you can do this also, you just by using threads. In order to make use of all the four or available CPUs, you need to look into parallel programming. Okay, in parallel programming, what you would try to do is maybe use multiprocessing. So each process has its own global interpreter lock, so which means one process can use one CPU, whereas another process gets to use another CPU. This way that even though you are executing the same piece of code using, but they are run on different processes on multiple CPUs, you are achieving true parallelism over there. Whereas in threading, you're not getting that complete true parallelism concept. So yeah, next is that okay, so now we know why threads are there and why we would rather use multiprocessing in those cases. When would threads be actually useful if you would consider? It's probably when you have a set of instructions. Okay, these instructions happens to wait over input. Okay, IO input, or you're reading data from a file, or you're waiting over something over the network. Okay, these are all tasks which are non-determined. I mean, like, you cannot determine exactly when they would finish off and come back to you, so you have to wait over them. In these cases, while waiting over any of these, the CPU can now continue executing other sets of instructions instead of sitting and waiting for this IO, or waiting for a network event to occur. So in those cases, threading makes the best sense, as you could execute another set of instructions while the previous thread is in the background waiting for something to occur. So okay, now in Python, in order to utilize the threading module, what we have is the thread module is also there, but we would be preferred to use the threading module, because the threading module is a good wrapper around the base thread module actually. There are multiple methods inside this. We'll look at the basic ones today. So in order to create a thread, you would need to first uh, call the thread object. So now that you know what a thread is, now when you do threading.thread, you're just telling Python that using the threading module, use the thread class. This thread class is actually the uh, the thread, your thread or the set of activities that you're going to run. This thread module can be given a set of instructions to run using the target. In the constructor of the thread module, wait one second, I shall show you here. If you were to see, okay, so yeah, here inside the threading module, you have a class called the thread. This is actually the main thread of control. This thread object, this thread class takes in a parameter called as target. This target should be given the function that you want to execute. So while given that function, it takes this and runs that on a specific separate thread. Now while doing that, it might need some arguments, this function. So in order to do that, you could give just args over here. This is another argument that you can pass to it, or you can pass keyword arguments, the krs here. um, so that's what these two actually mean. And you could give a name to your thread or group. Okay, the daemon part is actually interesting, where if you were to give the daemon equal to true, which means that even after the target function, whatever you have mentioned over here finishes, let the thread not die, let it stay in the background. So you would suggest something like daemon equal to true over here. But if you give none, by default it takes none. At the time of runtime, it inherits it from the parent thread or the main thread which is running, by which is also by default false, which means that, like, if you were to run a program in your init is actually your main thread, this init part. um, this thread has daemon equal to false, which means that when the execute set of instructions what are given to it finish executing, let it exit. So when you start a thread by default and don't pass in the daemon true, which means that it also fails. I mean, it also ends as soon as it finishes. Okay, so that is the parameters that you need to pass to this thread class. Okay, so you do something like this: thread1 equal to threading or thread, and then pass in a function called a sleep nav. That's a simple function which just sleeps for some specific amount of time. um, okay, just in a for loop you just iterate over every second and then sleep. Then there's another function which would randomly print characters, 6 characters over the screen. I'll explain why that is there. So now thread 1 is created and it's sleeping. um, if when you call it, you have just assigned the function to it. You have not yet told the thread to, okay, you should start and perform the actions whatever has been given to you using the target function. In order to invoke that, we need to call something called as a thread.start. This thread.start actually says this thread object, this threading.thread calls the class constructor with this function as its target and returns you back the object. So now thread 1 is our object. That object has a function called a start. Start basically says that you should execute this function by calling the run method. This actually the in threading, whenever you first is you initialize inside the thread method whenever you want to start. So what you would first do is you would one second, yeah, inside the thread first you would initialize initialize. You could initialize using the calling the threading.thread, and then pass in the parameters like target is equal to daemon equal to and name equal to. You could give stuff like this. Or okay, once you give stuff like this, right, now you've just initialized the class and you've got back one object, that thread object. Now using this thread object, right, you have to call this, wait a second, yeah, you would call the start method. So what the start method actually does is it actually calls this thread's internal run method. There is a method called as a run inside the thread. So what this run method does is it represents the state of activity. It invokes the callable object that is passed to the object's constructor, which means that only the moment when you call start. This start should be called only once over a thread. If you call it two times, you'll get exception. So once you call this run start method, it then calls a run method. You could ask why not rather call the run. You could do that, but the thing is that when you call via start, it internally calls run, and then that calls the sleep now. In cases where you want to directly call run, you would just inherit the whole class like this. So you'll subclass the threading.thread inside your own class and then override the run method with whatever function you want to do. Inside the run only you give the function what you want to complete, and then you would call the start method. That way you are overriding the run method and completing the task. So yeah, then there is another function called join. We'll look into join, but first, now if you were to run this program, you would be getting something like this. Okay, so there is a ident is a for it's a parameter. I mean, it's like it tells you what is the identifier of this thread 1. Then is alive will just tell you if this thread object whatever you are having is alive, and then is daemon is a check, I mean, is a function which tells you if this thread when it was created was it set with daemon equal to true or false. So yeah, those are there. Then when you call the start method, internally it calls its run function, and then that calls the sleep now. Sleep now is just basically going to print 1 to 10 in time dot sleep. I mean, in the range of 1 to 10. First sleeps for 1 second, then 0 1 2 3 up to 10. So now you see, now you started this thread. While this thread is going on, you could actually parallelly, since these are sleep methods, that means you're waiting for something to happen parallel. Now comes the interleaving actually, where you would start this next thread. This next thread just prints the messages over the screen, random messages, string 6 character length. So uppercase and digits, you would again iterate over the 10 seconds, 0 to 1, and you would sleep for each second, and then you're joining, you're going to print back that message. That's what this function does. Now if you were to run this program, you would see that for in no particular order, each thread is running on its own. So when thread 1 is happening, even at the same time thread 2 is also happening to us. So you are seeing two different threads which are running in the background. Now um, yeah, so that is with the start function. Start function just basically calls your run, and the run will execute the target function whichever you have passed to it. In order to now make sure that thread 1 has to finish, only then the thread 2 should happen. In that case, you would use a join function. This join function says that it should wait until the thread terminates. This is like a blocking call. Like until this thread finishes, the previous one, whatever you just started, and this object, which has to be started in order for it to finish. So when you call join, you have to make sure that the thread was started. That's one necessary thing. And you cannot call join over a thread that is already running, because that means a deadlock would occur, right? Like you're trying to wait for something that is already running. So yeah, now join, you call join means now if you were to run this code, you would see that this thread 2 never got started. It never even went into this state. Why? Because this was a blocking call. It has to wait for this thread 1 to finish, right? So yeah, you have to now wait for the thread 1 to finish, and then you would start with the thread 2. Advantage of this is that you are making sure that the threads which you started always complete, then only the next thread happens. So if I had to do this, so same thing, like now I'm making sure that this one is started, then as soon as that starts, thread 1 has to finish. Okay,